Bismillahirrahmanirrahim. Today I'd like to talk about direct variation and direct joint variation, inverse variation, and combined variation. Well, what does that all really mean? Well, this is when two variables are linked to each other. For example, this function over here, for y is equal to 2x. Now this is well known to us. This is the detention function. In other words, if you come in 3 minutes late, then you would be subjected to a 6-minute detention, so to speak, right? This is a familiar function to us. Y is equal to 2x, popularly affectionately known as our detention function. So in this case, the variable is x, and the amount of time a student serves in detention, which is 2 times the minutes that they're late, right? That's our detention function. So in this case, the variable is x, and the y, the function y, is directly related to x. In other words, how much time a student serves in detention depends on how many minutes they're late, and it's directly 2 times as much as time, right? So if they are 10 minutes late, 20-minute detention. 14 minutes late, there'll be 28-minute detention, right? So, and compassionately, we forgo that obviously many times, right? Anyway, so this is the detention function. In this case, y is said to be, the function is said to be directly related to x. So this is an example of a direct variation. Alright, so the detention function is actually an example of a direct variation. And this 2 over here, the 2 that precedes the variable, this variable is called the constant of variation. Those are the basic terms that we need to know. So that's the constant of variation. So when two variables are related in the simple fashion, where one is a multiple of another, like this, another example would be like something like g is equal to square root of 5 times k. In this case, g is directly related to k, and the constant of variation is going to be 5, square root of 5. So this is another example of a direct variation when between two variables. Now, if you take this, g is equal to square root of 5 plus k, and then you add anything to it, like a 3, this no longer is a direct variation. So the direct variation is simply in this form: y is equal to a times x, and this a again is the constant of variation. Alright, now this is a general way direct variation is written. If you add anything to it, it no longer is a direct variation. Okay, so this is a reasonably simple concept, right? We think, and we actually did this in Algebra 1. So y is equal to ax, all right, is an example of a direct variation where a is the constant of variation over here. Let me put it down over here. This is the constant. It's called the constant of variation, and y is said to be directly related to x. Now, it is also possible that y could be related to more than one thing, right? For example, y could be related to, like this, a times x times z. In this case, y is related to 2 other variables. In other words, x can be some variable and z can be some variable. Alright, so these are variables. And the a over here is again the constant of variation over here. Alright, so a is again a constant. It means it doesn't change. It would have to be given to you. So for example, if y varies directly with x and z, that means y is going to be, if somebody tells you, let's say somebody pulls you up on the street and they ask you, hey, did you know y is directly related to x and z? And you say, oh yeah, of course, silly, I know that because I read that, in our algebra class. We learned it the other day. So, but if somebody tells you y is related to x and z, the next y is directly related to x and z, you can formulate in your mind something like this. Okay, but then you would have to ask, oh yeah, y is related to x and z, but what's the constant of variation? So you have to ask them, what's the constant of variation? How is it related? Is the constant of variation 2? Is it 3? Or is it pi? Or is it square root of 5? So you have to be told what the constant of variation is. So someday, for example, if I walk into class, I say, I changed your detention function, it's a direct variation like this, but I have changed the constant of variation. Now, I'm sure you're very curious to know what the constant of variation was changed to. Is it greater than 2? Is it 1.5 now? Right? Or is it like, no, I don't know, 8 or something like that. So the constant of variation is very important because it kind of determines a lot of things, doesn't it? So when variables are directly related, it suggests that, in this case, y is directly related to x and z. There's some constant that is multiplied as a coefficient to those variables in an equation, in a function like this. Now, again, if you do anything else to this pattern, right? If you do anything else to this pattern, if you divide this by, now you can divide this by 5 because it's still a constant, that's okay. But if you divide this by another variable such as k, or let's put it like an m, that's no longer a direct variation, okay? So, or if you add something to it, or you subtract something from it like this, that's no longer a direct variation, okay? Now, this scenario, the first scenario where y is directly related to x, and you're talking only about one variable, that's called a direct variation. When we're talking about more than one variable, like this, y is directly related to x and z, when we're talking about more than one variable, that scenario is joint variation, or you can remember it as direct joint, because it's like there's so many terms here to learn. So direct variation, simple direct variation, or joint direct variation is another way of saying that. This is simple direct variation, this is joint direct variation. Maybe that's a better way of saying it. So this is joint, all right, direct variation, right? This is joint direct variation, and you can call this simple, that's my terminology, direct variation. So these extra words that I put in there is just to explain. So this is simple direct variation, and this is joint direct variation. You can have as many joint direct variations. So y could be related to a plethora of other variables. So if y is equal to some constant a, we use a for a constant. You could use any other variable, but we use a for a constant because it's the tradition, right? It's kind of like the mathematical sunnah, so to speak. So y could be related to x, m, z, p. This is y is still directly related. It's directly related to these four particular variables. That's like the joint direct variation. Okay. Now, speaking of using a as a constant, I have suggested before in class that in mathematics, typically when we use the alphabets a, b, and c like this, all right, and then in the middle number m like this, this is the alphabet, right? So as suggested before, traditionally, when we use the alphabets in mathematical equations like this, we typically use the beginning of the alphabet here to suggest constants. There's no law like this. It's just kind of like mathematical manners in a sense. So we use the first part of the alphabet for constants, and the middle part of the alphabet. And this, you will see this in the next two chapters. We use the middle part of the alphabet typically for integers. So if you want an integer constant, so typically use those for integers. And of course we use the very last part of the alphabet typically for variable quantities. Descartes started this tradition apparently. So first part of the alphabet is typically reserved for constants, in the middle part for integers, and the last part for variables. Of course, you can have constant integers, etc., but here the constant could be anything. It could be rational, irrational numbers, etc. Okay, so this is direct variation. So direct variation or simple direct variation, and direct variation or direct joint direct variation, and then there's two other categories that we have to study, and those are the inverse variation and combined variation. So when variables are inversely related, the relationship between them is like this: a over x. For example, a again is the constant of variation, so a again here is the constant of variation, and x is the variable, right? So if y is inversely related to x, you would write it like this. If y was inversely related to z, you would write it like this. No, you wouldn't write like that. That would be wrong. If y is inversely related to z, you would be like this. So in other words, in this case, all right, as x increases, the y decreases. So the relationship between here, the relationship between domain and range is like this. In direct variation, as the domain increases, the range increases in the same direction, right? So to speak, if the a is positive, right? So, but in this case, the relationship is inverse, right? Like this. If a is positive, right? If you were to, so this is example of inverse variation. Now, the last category is combined variation. The combined variation doesn't mean joint variation. Joint variation is for joint direct variation. Combined variation is combining inverse and direct variation. When you combine direct variation and the inverse variation, then you get the combined variations, okay? So if y was directly related to x and inversely related to z, you would write that y is directly related to x and it is inversely related to z like this. So this is an example of a combined variation, okay? So this is an example of a combined variation. Now, what are you combining? We're combining a direct variation and an inverse variation, and a here again still is a constant of variation. A is a constant term. All right. Now, I wanted to bring to your attention here. Watch, okay? If you were to graph something like this, y is equal to ax, okay, this would be a line. That is, the graph of direct variation is a line because it's like y equals mx plus b, except the b is missing or b is 0, right? So the graphs of direct variation are linear functions starting at the origin. So if you were to graph this is your tangent function, y is equal to 2x, the graph is a line that looks like this, right? If the constant of variation is negative, of course, the line would look like something like this, minus 3x, but it would still start at the origin, right? And then it would be going down like this. On the other hand, if a variable was inversely related, y is equal to 2 divided by x, then that's like our inverse rational function, and that's the reason why we're studying this topic here, because of the inverse relationship. Inverse relation would be a irrational function like this. So if variables are inversely related, it would be something like this. Now, we don't graph combined variation because you can't graph something like this with two variables. This is a three-dimensional graph, actually. You can graph this, but this would be like a three-dimensional graph for the future, inshallah. So, but direct variation graph are lines like this or like this. Actually, I could do a little bit better. Let me just draw a direct variation graph, and that's a line. And let me draw another direct variation graph let me draw a slightly different direct variation like this. So direct variation graphs would look like this, and inverse variation graph would of course be like rational functions. Okay, now that's kind of important to understand. Now, one famous example of all of this is the ideal gas law that you study, inshallah, in chemistry. The ideal gas law is this. See, this equation actually models the behavior of gases in ideal conditions. So where P is the pressure that the gas is subjected to, which is related to the volume of the gas that the gas will occupy, and the N is the number of moles, or how much gas molecules you have, and R is the constant here. See, in this case R is the constant. This is the constant of variation, okay, and T here is the temperature. So this ideal gas law, okay, this is famously known as the ideal gas law, is a great example where all of these direct variation or joint variation and combined variation concepts are all collated, or can be demonstrated in one swoop, so to speak. Okay, and this is the ideal gas law. Okay, now in this case, if I solve this equation for P, dividing both sides by V, I get P is equal to nRT over V, like this. And just for emphasis sake, R here is the constant of variation. So I could, if you wanted to, you could rewrite this like R being R is like the A. Okay, PV equals nRT. You could rewrite that, as like this. Okay, so in this case, you can say that the pressure is directly related to the number of moles, or N, and NT. So it's jointly related to N and T. So P is jointly related. So this is a joint variation, right? So joint direct. Okay. So this is a joint variation between pressure and the number of moles of gas, the quantity of gas, and the temperature that the gas is subjected to. And the pressure is inversely related to the volume. Okay, so pressure is directly related to the number of moles and temperature, or pressure is jointly related to the number of moles and temperature, and the pressure is inversely related to the volume of the gas. And the constant of variation is R. It's like 8.71 or something like this, a constant, and that value is given, and it's known, and it doesn't change for between different circumstances, as long as you're talking about ideal situations. And the whole equation, all of this, these two, direct, jointly direct relation, inverse relation. This is an example of a combined variation. Okay, now combined variations, relationships. Okay, now you can also see that you can solve the same equation. So you can solve the same equation, let's say, for T. If you have PV is equal to nRT, if you solve this equation for T, you can divide both sides by N and R. Okay, then you have T is equal to PV over nR. Now R is still the constant of variation, right? Like this. So R is still the constant of variation. Now, in this case, the constant of variation would be 1 over R, whatever that ends up being, right? But this contributes to the constant. Everything else in that equation is a variable. So then you can say that temperature is jointly related to pressure and volume. That is, temperature is directly related to pressure, temperature is directly related to volume, or temperature is jointly directly related to pressure and volume, and temperature is inversely related to the number of molecules that are present, right? For example, if you have a pressure cooker, see if you have a pressure cooker, right, and there's a certain number of gas molecules, if you increase the temperature over here, if you increase the temperature, the volume cannot change, right? So volume, because it's a pressure cooker, so right, so that if you increase the temperature, volume cannot change, and the number of moles does not change, the number of molecules does not change. So what has to happen? If you increase the temperature, the pressure has to go up, right? The pressure that the molecules are going has to go up. So if the temperature rises and the volume stays the same, the number of molecules stays the same, and the constant here doesn't change, the pressure in the pressure cooker therefore will have to go up. So this, now by how much? The beauty of this equation is you can predict exactly how much pressure what the pressure is going to be based on the temperature. So if you could measure the temperature inside the pressure cooker, and I'm sure you can, because I'm sure they have high-tech pressure cookers that give you temperatures, you can actually determine exactly how much pressure or how far away you want to stay away from the pressure cooker when you open it up. So this is a great example of a combined variation. Now, the questions regarding these typically on exams are reasonably simple. So the question will say, for example, the variables x and y. Okay, they'll tell you variables x and y are inversely related. Okay, so they tell you these variables are inversely related. So, okay, what does that tell us? Well, it's like the guy comes in on the street, did you know that x and y are inversely related? And says, yeah, but what's the constant of variation? So you go, y is equal to, so if somebody tells you x and y are inversely related, they're telling you this, but they're not telling you, okay, the constant of variation. Then the next question is, what's the constant of variation? Well, it says, I don't know what the constant of variation, but I do know that when x is equal to 4, then and y is equal to 7. So the guy goes, so hey, you told me that x and y are inversely related, but you don't know the constant of variation? The guy's like really embarrassed, and he goes, yeah, I don't know what the constant of variation is, but I can tell you when x was 4, y was 7. Well, then you sit down with the dude and you teach him some algebra on the sidewalk, So you pull out your notebook and you start teaching us some algebra. I don't recommend it, of course. You know what I'm saying? Don't talk to strangers, right? All right, not until you're grown up. So even then, I wouldn't talk to strangers. Bring them to us, so I would teach them. Now, anyway, so when x and y, so when x is equal to 4, y is equal to 7, says, well, you know what, let me tell you, if you know x is equal to 4, y equal, I can find a constant of variation for you. Okay, let's go, yeah, how do you do that? Well, easy peasy, silly. You put 7 is when x is equal to 4, y is 7, and then we're going to go solve for solve for a, the constant of variation. And how do you do that? Well, easy peasy. You just multiply both sides by 4 over here, like this, and then you get a is equal to 4 divided by 4 is 1 is equal to 28. So now you know what the constant of variation is. Now what you must understand is this is a constant. It's just that the guy didn't know what it was, but so we had to kind of like do our own mental math to figure this out, right? So now you can say, however, that the relationship between y and x is the following: 28 over x. Now you know how y and x are related. Now you can use this equation. Now you can go tell to do, hey, look. Now don't go around telling people how x and y are inversely related. Okay, don't go tell without telling them the constant of variation 28. So the dude goes around and telling everybody, no, x and y are inversely related, and the constant of variation 28. He's got a big smile on his face. Now he tells that because then you can ask, what's the value of y when x is, I don't know, 2, right? So once you have this basic equation, you can apply to any, and you can given any x, you can find y, and given any y, you can find x2, right? So you can use this. So when x is 2, y is going to be 14. right? Just like if you know how much time you have to serve in a detention equation, right? Just because you know the constant of variation, that is 2x. So many of these questions will have you find the constant of variation, okay, and then use that knowledge to solve whatever equation that you want to solve. Okay, here's another example that's given in the book. It says the variable z is jointly related to x and y. Okay, z is jointly related to x and y. That means z is like this. So z is jointly related to x and y, meaning like that. And then we don't know the constant of variation. You just write it over there. Okay. So we don't know yet what the constant of variation. So we write that over there. So z is jointly related to x and y. And then it says when z is equal to negative 75. So when they tell you when z is negative 75, x is equal to 3 and y is equal to negative 5. Okay, that's a given information. So now you're given some value for z and given some value for x and given some value for y. Well, that's easy peasy. Because then you can substitute all of that. So you can say negative 75 is equal to a times 3 times negative 5. Okay. And you can solve this for a. So negative 75 is equal to negative 15 times a, and then you divide both sides by negative 15, and then you get a to be 5, right? Correct? So then you have your equation. Now you know z is jointly related to x and y, and the constant of variation is this, right? So now you have your joint variation equation. All right, so that's easy enough, and it's all of these questions are similarly easy, even if they were inversely related, like this. Okay, so this is an example of a combined variation with z is directly related to x and inversely related to y. And you would do these questions very similarly. Inshallah, I hope that was not too difficult. I think this topic is reasonably easy. And then these are popular questions also on standardized tests and things, I think. So it's good to master this topic, inshallah. Until next time, as-salatu wa-salamu ala rasulillah wa rahmatullahi wa barakatuh. Assalamu alaikum.